Okay, so for this video, we are going to discuss a few permutation and combination questions from past year paper. All right. Okay, so for this particular question, it is actually from October, November 2010. It is from paper 6.3. Right. Okay, so let's start with our discussion here. All right, so the diagram here shows you that there's a small aeroplane with 14 seats for the passengers, and this is a layout lah. All right. Okay, so 12 passengers board the aeroplane. So from here, I think 14 is important. And then you are having 12 passengers also, which is very important number. Okay, so how many possible seating arrangements are there for the 12 passengers? Give your answer correct to three significant figures. Okay, so for the first part of this question, generally it is quite straightforward because you're having more space, more seats than the passengers. So you want to arrange 12 passengers into 14 empty seats, right? So we need to arrange, therefore we have to use permutation. Okay, or maybe you can see the keyword arrangement, right? So every time when we see the word arrangement, or maybe yeah, mainly it's arrangement or order lah, right? Then you should use the permutation where it mostly involve p or factorial, right? So we are having 14 seats and we want to arrange 12 passengers in the 14 seats to the 14 seats, so it will be 14 p12, right? So when you press calculator, you will get a very long number with um 10 power 10 at the end. All right, of course, you should correct it to three significant figures as mentioned in the question. So it will become 4.36 multiplied with 10 power 10. So this will be the answer for the first part. Okay, all right, then now let's continue to the second part of the question. So these 12 passengers consist of two married couples where they have Mr. and Mrs. Lin and also Mr. and Mrs. Brown, 5 students, and also 3 business people. So they are having different groups up of the passengers. Right, so question number 2, part number 2. So the 3 business people sit in the front row. Right, so you can see that there are some restrictions in already. So we must have 3 business people sitting in the front row, 5 students sit at the window seat, and then the couples should be sitting at the same row and also at the same side. All right, okay, so how many possible seating arrangements are there? So according to the different groups of people, we are having different restrictions here. So usually when we want to arrange them, we have to start with those arrangements first. Right. Okay, so first of all, I think the first arrangement, the first restriction that we should consider is this: 3 business people sit in the front row. Because if the front row is occupied by other people, right, then this restriction cannot be fulfilled. So this is the first restriction that we should try to fulfill first. Okay, so 3 business people sit in the front row. So for front row, you are having 3 seats and you want to arrange 3 people in. All right, so that means you are having 3 factorial or 3p3. Okay, so the 3 factorial can be replaced as 3p3. That means you want to arrange 3 business people to be seated at the 3 empty seats. So 3p3 or 3 factorial, the answer is the same. Okay, all right, so that means the first row here will be occupied for the business people. And after that, we continue further. Right, so next, students must sit at the window seat and also the couple must be sitting at the same side, okay, same row. So maybe for me, I think the couples restriction is more important because if there are some students already occupied the seats, the couple seat here, the double seat here, that means the couple cannot be seated correctly. All right, so for me, I think the second part, second restriction that we should consider should be the couple, right? Okay, so for the couple, we are having 3 couples. Oh, sorry, we are having 2 couples, all right, and we want to arrange them into this 3 set of the couple seats, 3 sets of the double seats. Okay, so there are 3 sets of the double seat, and we want to arrange two pairs of the couple. So it should be 3p2. So each pair of couple, we will assume that they are 1 unit. All right, so that means we are trying to arrange 2 units into 3 sets of the seats. Correct or not? All right, so there are 3 sets. First one, second one, and also the third one. So you want to arrange 2 couple inside. So it should be 3p2. All right, so after you arrange the couple into the seat already, okay, let's say Lin and Lin will be sitting here. One is Mr. Lin and one is Mr. Lin and one is Mrs. Lin. Maybe Brown, Mr. and Mrs. Brown is arranged to be here. All right, okay, so for Mr. and Mrs. Lin, because they didn't mention who should be sitting close to the window, all right, or sitting at the window seat, therefore we assume that they can actually having exchange, all right, between the couple. So maybe Mr. and Mrs. Lin can exchange their position, okay, or their seats. So it will be multiplied with 2 factorial. Then same thing happen for Mr. and Mrs. Brown, it will be 2 factorial. So this purple color handwriting here, okay, the ink here will be referred to the couples. So 3p2 means that you are trying to arrange 2 units of couple or 2 pairs of couple into 3 sets of the seats. And after that, since they can exchange their seating each other between the Mr. and Mrs., therefore you have 2 factorial and also 2 factorial. All right, so once we already fix the couples and also the business people, then the last one you should actually consider the students. So we have 5 students here and all of them must sit at the window seat. So how many window seats left? 1, 2, 3, 4, and 5. So that means no matter where the Mr. and Mrs. Brown and Lin sit, there will be one empty window seat between this side, okay, at this side. All right, so no matter how, in total there are 5 window seats here to be arranged, okay, or to arrange 5 students to sit at these 5 window seats. So it will be 5 factorial, or you can write it as 5p5. That means you want to arrange 5 students into the 5 empty seats. So it can be 5p5 or 5 factorial. Okay, so this will give you the same value, right? So once you complete, you have to multiply all the permutation together to complete the whole case. All right, so if you didn't do any careless mistake, then you should able to get 17280 as your answer. Okay, so this is what we have for part number 2. Right, okay, then now we proceed to part number 3. Okay, so for part number 3, if instead the 12 passengers are seated randomly, find the probability. So maybe you need to highlight the word probability lah. So they are not asking for arrangement anymore, but now they're asking for probability that Mrs. Lin sits directly behind a student and Mrs. Brown sits in the front row. Okay, so here we have 2 conditions also. The first condition is Mrs. Brown sits in the front row, and secondly, Mrs. Lin sits directly behind a student. Okay, all right. So we have to again start dealing with all the restrictions first, okay, before we can put other passengers in. All right, so according to this one, okay, the restriction here, I will think that Mrs. Brown sit in the front row is more important. Okay, all right, and after that, only I will consider Mrs. Lin sits directly behind a student. Okay, so Mrs. Brown sits in the front row. So for the front row, you are having three seats here, and you want to arrange Mrs. Brown in. Therefore, it should be 3p1, or it is just a 3 lah. All right, so 3p1 or a 3 means that Mrs. Brown can have 3 possible seats here. Okay, all right, or in other meaning means that 3p1 means that you want to arrange one person into one of the 3 empty seats. So it should be 3p1. So this is for Mrs. Brown. Okay, so once I settle the first condition already, then now I'm going to consider the second condition here. Mrs. Lin sits directly behind her students. Okay, so let's say, assume that Mrs. Brown is sitting here. Okay, after we arrange them, okay, so Mrs. Brown, let's say, sitting here. Then now we want to put in Mrs. Lin and also a student. So they said Mrs. Lin sit directly behind a student. So the layout of the sitting should be Lin at the back, and then the student must be in front, and they must come in pair like this, front and back. All right, so the front and back sitting plan. The front one is students, so the back one is Mrs. Lin. So if Mrs. Brown already got occupied this place, these seats. So how many possible arrangement we can have, okay, for students and also Mrs. Lin. So you can count it by looking at the sitting plan here. This is the first possible place or sitting that we can put them. This is the first one. This is the second one. Okay, so this is one. This is the number two. Okay, then after that, maybe this is the third one, three. This is the fourth. Okay, five. And then what else do I have? I have six, seven, eight, and then nine, and 10. So you can see that the possible empty space that have front and back sitting one, they are still they have 10 pairs of seat in front and behind. All right, so what we have here, it should be, I multiply it with, okay, 10. So the 10 here is the sitting for Mrs. Lin behind the student. Okay, so they are 10. All right, then after that, because we are having 5 different students, right? Okay, so that means this one can be student number 1, student number 2, student number 3, student number 4, and so on. So that means you have 5. Multiply it with 5. So this purple color one will be for Mrs. Lin with the student in front. And we also consider multiply 5 means that we have 5 different students. So she might sit with student 1 or 2 or 3 or 4 or 5. Okay, all right. So now we already completed the both restriction already. Then now we should arrange the remaining passengers. All right. Okay. So again, just now assume that I already put Brown, Mrs. Brown here, and then maybe Mrs. Lin and also the student here anywhere. Okay. So how many empty space do I still have now? So I still have 11 empty space. And how many passengers I still need to arrange them inside randomly? So I still have 9 passengers. So 11P9. And you multiply everything together to make sure that it is actually you multiply them together to make sure that it is a complete case, complete case, the complete aeroplane seating. All right. Okay. Then now for this question, because they are asking for probability, therefore these are the number of arrangement. Sorry, this is a number of arrangement. Therefore, okay, this is a number of arrangement. Therefore, you need to divide it by the total arrangement without restriction. So what is the total arrangement without restriction? Which is the answer in part 1. Okay, it will be 14, B, 12. All right. Okay. Then if you press calculator, the numerator that you should get should be 299,376,0000 divided by 14, P12. And your final answer should be 25 over 364, or you can correct it to 3 significant figure, which is 0.0687. All right, so this is how we solve this question. Okay, so now we discuss the question from October, November 2016, paper 6.2 and question number 6. All right, okay, so here they tell us that they want us to find the number of ways for all the 10 letters from this word can be arranged. All right, so again, highlight the word arrange. Okay, so this keyword tells you that you have to use either factorial or the NPR to get the answer later, right? Okay, so first part, the vowel A, E, O are together and also the consonants are together. All right, so when they want to arrange, they want us to ensure that the vowels and also the consonants are together. Okay, so now usually for this kind of question, I will try to figure out okay, how many identical letters that I have. So from here, I'm having C, O, P, and then H, A, G. Then I have 2E and also 2N. So from here, I think it's quite obvious. We know that there are E and N which are identicals, 2E and 2N. All right. So first of all, they want us to arrange the vowel together and also the consonant together. So when you see the vowel and consonant together, that means that for all the vowels, you are treating them as one unit so that they can be arranged all together in one group. Okay, then for the consonant also the same. We are having C, P, H, G, and N. So for all the consonant here, I will assume that all of these are also one group. Okay, so that you treat them as one unit. Therefore, when you are arranging them, they will not be separated. All right. Okay, so this is one unit and this is one unit. So first, you want to arrange these two items here. When you want to arrange two items, that means you are having two factorial. Okay. Then now we have to look into every single group in detail. All right. So now after you arrange in general these two groups, okay, now you need to consider the arrangement inside each group. So for O, A, E, E, there are 4 letters inside. They can exchange their position or they can arrange their sequence in the group within the group. Okay, so 4 letters means that you are having 4 factorial. But because of 2 identical E, therefore you divided it by 2 factorial. Okay, and multiply with, we're done with the vowel part, then we are considering this consonant part. So for consonant part, we're having 6 letters here, and they can exchange their position within the group. So that means you're arranging 6 items. So you're having 6 factorial. But again, because of the 2 identical N here, you need to divide it by 2 factorial. Alright, so after you considering all the arrangement within the group, then you can multiply everything together to get the number of arrangement. So it should be 8640. So this is what we have for part number 1. Okay, then now we continue to part number 2. Alright, so for part number 2, they are saying that the E's are not next to each other. Okay, when we are having the case that not next to each other means that they must be separated. So usually for the cases where we want to arrange something that must be separated, what am I going to do is that I will arrange them at last. So that means I exclude the E first, I arrange all the other letters first. So when I want to arrange all the other letters, I'm having C, O, P, H, A, G, and N. So I'm having 8 letters here, therefore it should be 8 factorial. Okay, and again, because of the 2 identical N in my arrangement of 8 factorial, therefore I need to divide it by 2 factorial. Okay, so this is the arrangement for the 8 letters with 2 identical letter N. And now I want to put in the E. So to put in the E separately, I have all the space here. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 possible spaces to put in 2 letters E. Therefore, it should be 9P2. Okay, all right. So because we are having 9 possible space to put in 2 letters E. And again, these 2 letters E are identical. Therefore, you have to divide it by 2 factorial as well. Then you multiply them to get the correct answer, which is 7,25760. So this is what we have for our second part. Here, right? Okay, then now we continue further. 4 letters are selected. Okay, so now please highlight the word selected. So again, selected means you should use combination method to solve it later, right? Which is NCR. Okay, so 4 letters are selected from the 10 letters of this same word here. Find the number of different selections if the 4 letters must contain the same numbers of E and N with at least one of each. Okay, so if you look at the restriction here, generally what you know is like you need to have 4 letters. You want to select 4 letters, and then from the 4 letters that you selected, right, the number of E and also the number of N must be the same number, which means that you can have one E and one N. Okay, out of the 4 letters, you can have one E or one N, or maybe 2E or 2N, or maybe 0E and 0N. But because in this restriction also they mentioned that at least one of each one. So that means at least one E and at least one N. Okay, so this is the first case and this is the second case. All right. So if you look at the first case here, since the E is in the selection already, although I'm having 2E, okay, although I'm having 2E, but no matter which E am I selected, right, they are still the same. That means they still look the same. They are still considered as one combination only. Okay, so for the E here, no need to take 2C1 because they are identical, right? Okay, so same thing happen for the N. Okay, no need to multiply with 2C1 because no matter which N you choose, right, at the end, the result, they look the same. Okay, which is one combination only. So now we want to focus on these two empty space here lah. So I need to actually get 2 letters to fill in to these 2 empty space. Right. So how many letters available for me to select? Okay, so I'm still have COPHAG. I should exclude the E and N into my consideration already. Okay, so I still have 6 letters available. Okay, which means that I want from the 6 letters, I want to choose 2 and fill in to these 2 empty space. All right, then when we come to the second case here, you will see that there's no empty space anymore. Okay, so that means this is actually one combination, one possible result. E and N is one of the possible result. Okay, no need to have 6C something. You can put 6C0 if you want. All right, so the final answer for this number of selection will be 6C2 plus 1, which is 15 plus 1, and you will have 16 as the total number of selection. Okay. Okay, so now we will discuss this question from May, June 2017, paper 6 to question number 6. Right. Okay, so a library contains 4 identical copies of book A. So I think all the keywords here identical are very important. Okay, so you have 4A, 2B, and also 5C. So these 11 books are arranged on the shelf in the library. Okay, so first part, calculate the number of different arrangement. Okay, so again, when you see the keyword arrangement, means that you have to use either factorial method or NPR, the permutation method, to solve and get the answer later. Okay. Uh, if the N books are either both book A or both book B. Okay, so the restriction here, they are saying that N books can be either both A or both B. So what does it mean? That means that out of the 11 books, when you want to arrange them, you can have N book is A and then A. In total, you have 11 books, right? So these are 2 books already. So 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Or, so this is case number 1. All the other cases, you might have both book B, okay, at the end of the shelf. And then you are having 9 books in the middle. 1, 2, 3, 4, 5, 6, 7, 8, 9. So total there are 11 books. So you're having 2 cases here, first case and also the second case. All right. So for the first case, if you try to rephrase the number of books that you have originally. I'm having 4A and then 2B and also 5C. So total they are 11. Okay, so now for case 1, when you have 1A in front, 1A at the back, so that means the center 9 books, the remaining 9 books will be, you still have 2A left, 2B and also 5C. So that means now when you want to arrange them, you are only arranging the 9 items or 9 books in the center. The end book, right, we are fix the books A there already. No matter which book A you fix, they are the same because here they already tell you that it is identical. All right. Okay, so you no need to consider which book A you should put in because they are identical. So that means no matter which book A you put in, they are still the same. So we are not going to consider anything with the end books. Right. So we only want to arrange 9 books in the center here. So we are having 9 books, right? So 9 items. That means we want to have 9 factorial. But out of the 9 books, there are some identical books, right? So I have 2 identical A, therefore divided by 2 factorial. I have 2 identical B, so I divided it by 2 factorial also. I have 5 identical C, therefore I have to divide it by 5 factorial. So this is how we get the number of arrangement of these books. Alright, so I'm having 756 for this case. Alright, then now when we come to case number 2, right, so for case number 2, right, the end books are B, both B. So that means no more big anymore. I have 4A to be arranged and also 5C to be arranged in this case number 2. So again, there are total 9 books also, 9 items. So that means I need to have 9 factorial. But out of these 9 items here, I have 4 identical A. So divided by 4 factorial, 5 are identical C. Therefore, I divided it by 5 factorial. Okay, so for this, I'm having 126 for case number 2. Okay, so to get the total arrangement, it will be the sum of these two cases. Alright, so the total arrangements will be equals to 756 plus 126. Therefore, I should get the answer, which is 882. Okay, so this is how we solve part number 1 for this. Alright, then we continue to part number 2. Okay, so calculate the number of different arrangements. So again, you can see the keyword arrangement again, right? If all the books A are next to each other. So I think I told you all before also, when I want to arrange any items that are next to each other, I will treat them as one unit. I will treat that as one item only. So that means if we assume that we bundle them together, the 4 items, the 4A together become one items only. Alright, okay. Then, and none of the books B are next to each other. So for book B, when they are not next to each other means that they must be separated. So must be separated, I will arrange them at last. Okay, so that means now I'm having the 4A all together. I have the 5C here, can be separated. 1, 2, 3, 4, 5, 5C here. So first of all, I need to arrange all these items here. How many items do I have? 1, 2, 3, 4, 5, 6. So I'm arranging these 6 items here, which is 6 factorial, but I need to divide it by 5 factorial. Why? Because of the 5 identical C. This one is identical, right? Therefore, I need to divide it by 5 factorial. Alright, after that, usually we need to consider the arrangement in the A, in the group, okay, within the group. So all the A here, there are 4 A's around, so divided, I'm having 4 factorial, but because of all of them are identical, therefore I divided it by 4 factorial also. So you can see that 4 factorial divided by 4 factorial is the 1. So usually for us, we are not going to write this out because it's just a 1. Alright, but if let's say I want to tally with the method that I teach before, okay, so this is how we get the answer. So you consider the arrangement inside the group, within the group, 4 factorial, but I divided by 4 factorial again because of the 4 identical A. Alright, so once you completed with the general arrangement, then now you need to try to bring in the book B. So book B must be separated. So separated means that now you need to see how many possible space I can slot the B in. So I'm having one space here, 2, 3, 4, 5, 6, 7. So there are 7 possible space that I can arrange in 2B. So that means 7P2. Okay, but again, because of the 2 identical P, you need to divide it by 2 factorial. Alright, so this is the complete steps. Then after you press the calculator, you should be able to get 126. So this will be the final answer for this particular question. Okay, so now let us discuss the question from October-November series 2017, paper 6.1. Okay, and this is question number 6 from this paper. Alright, there's a village hall with seats for 40 people, so that means you are having 40 seats. Okay, so consisting of 8 rows with 5 seats in each row. So I think this is very important as well. Okay, so we have 5 persons here. Mary, Ahmad, Wayne, Elsie, and John are the first to arrive in the village hall, and no seats are taken before they arrive. Okay, so first part of the question, how many possible arrangements? So again, highlight the word arrangement. That tells you that later when you want to solve this question, generally we are using the factorial or the permutation method, the NPR. Okay, so how many possible arrangements are there of seating for this 5 person if there are no restrictions? So again, usually for no restrictions question, it will be very, very simple and very straightforward. So you are going to put or arrange 5 person into 40 empty seats. So 5 person into 40 empty seats, we will be 40P5. Okay, so 40P5, that means you arrange 5 person into the 40 empty seats. Alright, so the answer that you get should be 78960. Okay, so here we done the first question, first part. Alright, then now we go to the second part. Okay, so how many possible arrangements are there? So again, you see the keyword arrangement. Alright, they are saying that Mary and Ahmad sit together. So these two persons sit together means they are sitting next to each other. Alright, so sit together is the keyword also. And they are sitting in the front row only. Okay, so this is one of the restrictions here. These two persons must be sit next to each other. Okay, sit together, right? So sit next to each other in the front row. Okay, then the other 3 also sit together again. Okay, in one of the other rows. So if they can sit together in any other rows, in one of the other rows. All right. So maybe for us, we are going to arrange Mary and Ahmad first. So when they say like this, that means when you want to arrange Mary and Ahmad, you have to assume that they cannot be separated. You have to treat them as one unit. But there are 2 persons here. Okay, 2 persons in one unit because they cannot be separated. All right, so you have to imagine now I'm having 5 seats in the front row. This is the front row with 5 seats. And if I want to put Mary and Ahmad in, so you can see that how many possible pairs of seats I can put them in. So this is the first one. That means this one can be the first one, Mary and Ahmad. Okay, or the second possible seating is this one, this pair. Okay, then the third one might be this. Okay, or maybe I can redraw it in a better way because I think this is quite hard for us to see clearly. Okay, 1, 2, 3, 4, 5. We have 5 seats here. Okay, so the first pair of seats I can put them here. Okay, Mary and Ahmad. The second possible arrangement will be here. Okay, then this is the third one, and this is the fourth. All right, so that means to place Mary and Ahmad together in the front row, there are 4 possible pair of seats that I can put them in. Okay, after that, you need to consider that Mary and Ahmad, they can actually exchange their position. So when two persons can exchange their position, it can be 2 factorial. All right, so for this is for Mary and Ahmad sit together in the front row. All right, okay, then done with the Mary and Ahmad. Now I want to arrange another 3 friends together. All right, so the 3 friends here will be Wayne, Elsie, and also John. So again, sit together means that they cannot be separated. So you have to assume that they are one unit like this. WEJ is one unit, and you want to put them in the same row. Okay, so how many ways can I put them in? So you can see that three of them are. So this is 1, WEJ, right? You can see that W, E, then J. So this is the first place I can put them. And after that, the second one will be this. And the third one will be these 3 seats. Okay, so that means for these 3 persons, to put them in the same row, you are having only 3 possible sittings for them. And after that, you need to consider that they can exchange their position between all of them. All right, so that means they should be 3 factorial. All right, for 2 persons, that means 2 factorial to exchange each other, the place with each other. So for this one also, we can consider that there are 3 factorial because you want to arrange these 3 persons into a group, all right, exchange their sequence of position in the group. So it should be 3 factorial. And after that, we have one more important part here is this one. They said they can be sitting at one of the other rows. So we are having 8 rows in total. Front row occupied by Mary and Ahmad already. Therefore, we still have 7 rows that can put them in any one of the row, right? So you have to multiply it with 7. Okay, so in short, you can see that this is actually for these 3 persons, the other 3. Okay, so this is for other 3. All right, then you have to multiply the permutation together to get a complete case for these 5 friends here. All right, if you multiply correctly, you should get 1008 for this part. Okay, so this is how we actually write it out. So this one is for Ahmad and Mary, and this part is for the other 3 friends, Wayne, Elsie, and John. Okay, all right, so we done part A. Then now we continue to part number B. Okay, so for part number B, in how many ways can a team of 4 people be chosen? Okay, so again, please highlight the keyword chosen here. So you see the word chosen means that they involve combination, which is NCR. All right, so you want to select 4 people from 10 people. If Rose and Lionel refuse to be in the team together. All right, so for this question, there are a few ways to solve it. All right, so maybe the easier way will be, since they don't want to be in the team together, right? So maybe for me, I will try to get the combination that both of them together. Then I take the total selection minus the case for both of them together. Okay, because if let's say you want to consider other case, so the steps are longer. So maybe some of you might think that, okay, Rose is in the team, then Lionel not in the team. Okay, then the second case is Lionel Lionel in the team, and then Rose not in the team. Okay, and then the third case is both not in the team. All right, so you have to consider so many cases here if you want to really fulfill what they want here. So for me, I will choose to do it in the other way. That means I find out both Rose and Lionel in the team. So what is the possible combination? Right, when both of them in the team, that means 4 person, right? Rose and Lionel already occupied 2 space, okay, or 2 space, right? So I still have 2 empty space. And how many people I still have? Originally, I'm having 10 people here. and because both of them are already in, I have 8 people left. So out of the 8 people, I want to choose 2 of them to put in the team. So this will be 8C2 if both of them are in the team. And now I want to consider the total combination without restriction. Total combination without restriction. Okay, so the answer will be very straightforward. You are having 10 people originally, and you want to choose 4 to form a team. All right, so it will be 10C4 for the total combination without restriction. All right, then after that, if you want to get the answer for this question, it is actually 10C4 minus 8C2. That means you minus the possibility, or maybe you minus the number of combination that both of them are in the team. So from here, you can get the answer in a more easier way, which is 182. Okay, so this is how we solve this question. Okay, so now we want to discuss October, November 2017, paper 6.3, question number 6. Okay, there's a car park with 18 space for cars arranged in a line. So on one day, there are 5 cars of different makes. Okay, so highlight the word different makes. This is very important because it actually tells you that none of the car are identical, right? Okay, so all the cars are different. Okay, park in randomly chosen positions and 3 empty spaces. Right, so first part of the question, find the number of possible arrangements. So again, highlight the word arrangement, tells you that you have to use NPR or factorial to solve the question, right? Of the 5 cars in the park. Okay, so you're having 5 cars to arrange them into 18 space. All right, so the answer can be very straightforward. It will be 18P5. So 18P5, you'll get the answer 1028160. Right? Okay. Then now, after that, they want you to find the probability. Okay, so again, they are asking for probability. Please take note on this, that the 5 cars are not all next to each other. Okay, so when they are mentioning about not all next to each other, it is actually the opposite meaning of all next to each other. So that means you should try to find out all the 5 cars next to each other first. Then you take the total arrangement minus all next to each other to get not all next to each other. Okay, so I will focus at all next to each other first. Okay, so when we want to find out the number of arrangement for 5 cars all next to each other, how can we find it out? Wait, so all next to each other. Okay, so since the 5 cars are all different, right? So we have car 1, car 2, car 3, car 4, and car 5. Okay, so we have these 5 cars here. Okay, and then you have originally 18 space, but when you put the 5 cars in already, you still have 13 spaces. All right, so the 5 cars here and also the 13 spaces. All right, and then these 5 cars, I will treat it as one unit because they must be all next to each other. So it must be, I will treat them as one item only, all these 5 cars, so that the arrangement for these 5 cars are all next to each other. Right, so this is one unit, and you are having 13 spaces, which is 13 units. So 13 plus 1, total are 14. So that means you are going to arrange 14 objects. So it will be 14 factorial. Okay, but all the 13 spaces here, they are identical spaces. Alright, therefore you have to divide it by 13 factorial. Alright, so 14 factorial divided by 13 factorial, you will get the answer 14. Okay, so this 14 factorial divided by 13 factorial, I get the step by using this explanation. That means I'm treating the 5 cars all together as one unit with the 13 spaces left. So I arrange all of them together, which is 14 units, 14 factorial, divided by 13 factorial because of the 13 identical spaces. All right. So the answer for 14 factorial divided by 13 factorial is actually 14. Okay, so if you don't understand this method, then you can use a more easier to understand method. Okay, but to me it is a bit long. You can try to arrange out. You can try to draw out 18 spaces. 1, 2, 3, 4. Okay, so you try to arrange. You try to draw out 13 spaces, 18 spaces here. Make sure you don't miss out any. Okay, I double check again. Okay, 18 spaces here, and after that you want to put the 5. Okay, so the 5 cars together, so that means they must be all together here, so you can try to count lah. So that means the first car start from here, right? So 1, 2, 3, 4, 5. This is C5. Okay, so this one as the first possible space. Okay, and then after that the second one will be 1, 2, 3, 4, 5, second space, and after that the third one will be 1, 2, 3, 4, 5, the third place to put in the 5 cars, and after that you repeat again the fourth one. Okay, and so on until the last space here. So if you count how many total space here, it will be 14. So this is another way of counting to ensure that all the 5 cars are next to each other. Okay, so you can either use this method where you count it straight away, all right, according to the position that we have. All right, so if you continue counting like the way that I show you here, you will have 14 in total. So that means it's 14. Or you can use the way that I told you just now, right? You are arranging 14 items, then 13 items are identical. Therefore, you have to divide it by 13 factorial. Okay, so after you arrange the 14 items with the 13 divided by 13 factorial already, now you need to consider the arrangement between these 5 cars. All right, because it is not necessarily must be car number 1 in front. Car number 1 can be at any place in these 5 spaces. Therefore, you have to multiply the 5 factorial. All right, so if you take 14 factorial divided by 13 factorial, multiply with 5 factorial here, you will get 1680. So this is the number arrangement for 5 cars next to each other. Okay, all right, then now I want to calculate the probability. So I want to calculate the probability that 5 cars are not next to each other. So that means it is actually the opposite meaning of all next to each other, right? It's the opposite meaning for this one. Okay, so to get the probability, I need to take 1 minus all next to each other probability, which is 1680 divided by the number of arrangement without restriction, which is 18P5. Or you can put in the answer 1028160. Alright, so 1 means the total probability minus all next to each other probability. Alright, okay, so when you press calculator, the answer that you get should be 0.998 correct to 3 significant figure. Alright, so in opinion, I think this is the easier method to get the answer for this part. Alright, okay, then we proceed to next question here. Okay, so we have another question here. On another day, there are 12 cars of different. Again, so you can highlight the word different. Tells you that they are not identical. Okay, so are parked in the car. 5 of these cars are red, then 4 are white, and 3 are black. So they want to select 3 of these cars. Okay, so find the number of selections. So again, now please highlight the word selections. Tells you that you are using combination method, which is NCR, to get the answer, right? So find the number of selections include cars of at least 2 different colors. So this is the restriction that we have. When we select the 3 cars, we must have at least 2 different color. All right. So now, for this one, I think we need to list out all the possible cases. All right. So we are having red color, we have white, we have also black. Okay. So in total, I have 5 red car, then 4 white cars, and also 3 black cars. Right. Okay, so first case, because I want to select 3 of these cars and must have at least 2 color. So the very first possible case, I can actually consider each color I select 1. Okay, that fulfill the conditional. I select 3 cars in total and also with at least 2 colors here. So for this case, I'm having all the 3 color. Okay, all right, so this is case number 1. How about case number 2? So for case number 2, what we might have is we can have 2 red car, 1 white car, no black car. Okay, so the total selection of car here is also 3, right? 2 plus 1 equals to 3. And I have red and white, which means 2 color, 2 different color. All right, then from this part, I can also have another possible selection, which is 1 red car, 2 white car, 0 black car. So that means I'll still keep black car 0. Okay, so it can be 210 or 120. Okay, so this is the possible case that I have. Okay, then now what are the other possible cases that I have? So maybe I'm having 2 red car, there's no white car, but 1 black car. So now again, I still assume that I have 0 white car, so I can have 1 red or 2 black, or 2 red with 1 black. So this also fulfill the condition. Okay, so next one, what is another possible result? I can have no red car, then 2 white and 1 black, or keep red as 0, then you have 1 white and 2 black. So from all the possible cases here, you can see very clearly that in total, I select 3 cars and I have at least 2 colors from all the selection here. Okay, right, so now we calculate the selection, number of selection. Okay, 1 red, 1 white, 1 black. So 1 red means 5, choose 1. Multiply with 4, choose 1. And multiply with 3, choose 1. Okay, so when you multiply all of them together, it will be 60. Okay, then for the second case, it's the same. 5, choose 2. Because originally you are having 5 red cars, right? And then you want to choose 2 of them. Multiply with 4C1. Multiply with 3C0. So for this, you will have 40. Okay, then 5C1 multiply with 4C2 multiply with 3C0. Again, for this case, you will have 30. Alright, so you are doing the same thing throughout all the cases here. Okay, and after that, you just need to total all the number of combination. Alright, so please make sure that you don't do any careless mistake. Okay, so for this one, I'm having 5C1. Okay, I'm having 15. Then the last one, I'm having 5C0, 4C2, 3C1, which is 18. And then 5C0, 4C1, then 3C2, and I have 12. Okay, so to get the final answer, you need to total all the cases together. Alright, then you should have 205. That means the number of possible selection will be 205 for this case. Alright, so in my opinion, I think this is an easier way for us to get the number of selection by listing out all the possible cases.